Okay, we're going to be working on 4.8 complex numbers. And complex numbers uses the imaginary unit, and these are going to be called imaginary numbers. And what that unit is an I. We don't use I as a variable because I represents this value of the square root of -1. Now, before you weren't ever able to take the square root of a negative number. But now with this imaginary unit of I, now we will be able to continue on with those problems when that comes up, and we'll be able to finish solving them. Okay? The other thing you need to understand, I'm going to go through it, just like when you have a square root of 3 and you square it, that's going to equal 3. If I have the square root of 5 squared, that's going to equal 5. Basically, that square root and the squared basically kind of cancel each other out, so you're just left with the number that's inside of that radical. Okay? So what you need to know is that if I have the square root of -1 squared, that's going to equal -1. So what that means is that I squared, because I squared is the square root, or I is the square root of -1, that means that I squared is going to equal -1. Okay? So basically what you need to understand is anytime that I squared shows up in a problem, you're going to replace it with -1. So when I have a square root of a negative number, now I'm going to be able to simplify that. And all you're going to do, you're going to simplify it the same way you would simplify a regular square root, except you're going to bring out an I from the radical. So the square root of -a is going to equal I times the square root of a. And then you'd have to simplify that square root. Well, here's some examples. If I have the square root of -4, that's going to be I times the square root of 4. Well, the square root of 4 is 2, so that becomes 2i. And we write the 2 first just like it was a coefficient to a variable. The I is going to be after that when they're multiplying. Another example, if I have the square root of -18. Well, I know because it's a negative, I'm going to have an I on the outside of a radical. 18 isn't a perfect square, so I do need to simplify that. You can do the birthday cake, the factor tree, use your perfect squares. I'm going to go ahead and do the birthday cake. Divide by 2, and that's 9. Divide by 3, and 3. Divide by 3 and 1. And I have a pair of 3's, so that means a 3 is going to come out, but don't forget I had this negative here. So what that's going to do is also bring the I out, and what doesn't have a pair that stays on the inside of the radical is the 2. And now that becomes a positive because I brought that I out of the radical. I know sometimes the imaginary, the I can get a little confusing about understanding what it is and why we use it. If you have questions, write them down. I'll talk a little bit more about them in class, okay? But write down the questions anywhere on your notes that you have questions so that I can answer them first thing. The standard form of a complex numbers is going to be A plus BI. The A is going to be the real part. That means the part of the complex number that does not have the I. The BI is the imaginary part. So this is where it's different from variables, is that you put the real part first, the one without the I. You put the imaginary part second, the one with the I. So try to remember to write everything in standard form like this as your answers. So when we're adding and subtracting complex numbers, you're going to use the same rules that you would if you were multiplying or adding and subtracting expressions with variables. Okay, so if I have like 2 plus 5i, and I'm adding that with -3 minus 2i, all I'm going to do, well, first I like to get them outside of the parentheses, so this is 2 plus 5i. Because this is a plus, it's just going to be minus 3 minus 2i. The signs in front of the terms stay the same. And now it's just combining your like terms. 2 and negative 3 combine to be negative 1. Positive 5 and negative 2 combine to be positive 3i. So that's adding complex numbers. The only difference with subtracting complex numbers is that you have to understand you're subtracting this whole term, that whole parentheses. So what you need to do, I'm going to do the same thing. I'm going to get these out of the radical, or I'm sorry, out of the parentheses. So this is still 4 minus 3i. But because I'm subtracting this parentheses, I'm going to distribute the negative into it, and that's going to make this a plus 4 and minus 3i. Now it's the same. Combine your like terms. Positive 4 combines to be positive 8. Negative 3i, negative 3i, they don't cancel out. They combine to be negative 6i. Same sign, add the numbers, keep the sign. So here I'm multiplying complex numbers. And I have 3i times the parentheses, negative 5 plus 2i. So I'm going to distribute negative 3i times negative 5 is going to be positive 3i times negative 5 is negative 15i. Just like if it was an x, you do the same thing. So positive 3i times positive 2i is going to become positive 6i squared. The only difference is now I need to do one step further. Because we said that I squared is equal to negative 1, what I need to do is replace that I squared with negative 1 and multiply it with the 6. So I have negative 15i, and positive 6 times negative 1 is negative 6. And now I'm going to write it in the standard form with the real part first, which is negative 6, then the imaginary part, negative 15i, and that's my simplified form. The biggest thing here is remember whenever you get the I squared, just remember to replace it with a negative 1 and then write it in standard form. So here I'm still multiplying complex numbers, but in this one I have two binomials being multiplied. And if you remember, when you multiply binomials, you need to distribute twice. Like first distribute the 4 into this binomial and then distribute the 3 into the binomial. Or you might remember it as FOIL. Your first, outer, inner, last. Okay, so when I do 4 times negative 1, that's going to be negative 4. 4 times negative 2i, well, positive times negative is negative. 4 times 2 is 8, so I have negative 8i. Then I have positive 3i times negative 1 is negative 3i, and positive 3i times negative 2i is negative 6, but the I times I will make I squared. So then I have negative 4. These two are going to combine to be negative 11i, and what happens with that one, it doesn't combine with the other i's because it's I squared. I'm going to multiply that with negative 1, so I have negative 4 minus 11i, this becomes plus 6, and now I can combine my like terms together. Negative 4 and positive 6 becomes positive 2 and minus 11i. Okay, so for this next one, same thing. Negative 6 times negative 6 becomes positive 36. Negative 6 times negative I becomes positive 6I. Positive I times negative 6 is negative 6I, and positive I times negative I is negative 1I squared, or negative I squared. So I have 36. What happens with these two in the middle? Positive 6I, negative 6I cancel out, and this becomes minus I squared, which we're going to change to negative 1, and minus negative 1 then becomes plus 1, and 36 plus 1 is 37. So sometimes it can happen to where the i's will cancel out and you end up with a real number with no imaginary part. Okay, here are some U-try problems, and we'll go over these first thing and answer any questions first thing in class. Okay, so I got a good joke for you today. It's not cheesy at all, I promise. What's black and white and green and black and white? Two zebras fighting over a pickle.